Hey guys, welcome back. Mr. Anderson here again with you for a little bit more Algebra 2. We're in Chapter 6, Section 3, and we're talking about the square root functions and square root inequalities. So let's just get right to it. We've seen a little bit of this in the last lesson, just a little bit, and this shouldn't be too bad today. Our objectives, first of all, we want to be able to graph and analyze square root functions and graph square root inequalities. So basically we're just kind of doing some stuff with graphing here today. Alright, this is first of all the parent function for square root. Just kind of do that. Hopefully I won't cover myself up in the corner there. Alright, so the parent function here, remember before when we've done other kind of graphs, we've talked about there's a parent function, and then based on that, you can change some things about it. Same kind of thing here. So the parent function, if you see, oops, I guess I don't have my, there we go, is f of x equals square root of x. So in other words, y equals the square root of x. That's your parent function there. And so a couple things about that. What's going to happen here is it's going to start, the parent function y equals square root of x starts at 0, 0, and then it goes up kind of this direction, kind of on a curve like that. It does not go past 0, 0. If you type something in your calculator, and I'll show you when we do one a little later, all the values past this that you think it might continue down this way, it all says error, error, error. You won't actually get an actual number. Why that is because once you get past this point, what's happening here is the x under here, you're getting a negative value under here. And do you remember what happens when we have the square root of a negative number? That's when we get imaginary numbers. And imaginary numbers don't show up on the calculator. So that's why we can't, we get, and you'll see it's going to say error for everything past that. When you get a negative number under here, under the square root, that's basically where this stops. That's the end of it. The domain, if you notice here, the domain, since this is what the graph looks like, the domain are the x values. So on this graph, where are all the x values on the graph? They start at 0, and they go 1, 2, 3, they go out to the right. So greater than 0 for the domain, here it is. And then the range is up and down, remember. So where are all the values on this graph? There's for y, they're starting at 0 and going up. So that means they're also greater than or equal to 0 for the range. So domain x greater than or equal to 0, range at y, I guess, is greater than or equal to 0 there. Okay, I might come back and talk about this a little bit more, but let's go to the next one. Alright, so domain and the range of each function. So here now it's saying, hey, here's your stuff. In a little bit we are going to get to the calculator, but for right now I want to show you just kind of how you can figure a few of these things manually. Every once in a while you might need to do that rather than use the calculator. Remember what I was just talking about with the imaginary numbers? When this stuff under the square root gets negative, then that's where your graph ends, because it starts with the imaginary numbers. So to find the domain we want to find where x, we want to be x minus 2, or whatever's under the square root, has to be greater than or equal to 0, or in other words, positive. You can't have x minus 2 being negative, so it has to be greater than or equal to 0. So this is how we find the domain. We just say, well, x minus 2 has to be greater than or equal to 0, so we solve this, plus 2, plus 2. So we've got that x has to be greater than or equal to 2. Okay, so that is our domain on this one. Our domain is that x has to be greater than or equal to 2. Because if we put 2 in here, and that's actually, this is how we find our range then, is if I put this 2 in here, that we found? 2 minus 2 is 0. Square root of 0 is 0, right? And so if I plug this value back in here, remember f of x is y, so then I'll find out what y would be, and in this case, y would be greater than or equal to 0. Okay, once I plug 2 back in here, 2 minus 2 is 0. And in a second, I'll talk about kind of an easy way to know whether this is greater than, or sometimes you could have less than here. And on the next, I think it's on the next screen I talk about it, but basically, if this is positive in front of the square root, this is going to be greater than. If there's a negative in front of the square root, it's going to be less than. And you'll see that in a minute. All right, one more, and then we'll look at the next one. Okay, so let's do the same thing here, domain and range. All right, so we want to, in this case, there's the next stuff. In this case, we want to see what makes x plus 6 greater than or equal to 0. Okay, because this has to be greater than or equal to 0, so minus 6. X is greater than or equal to negative 6. That's our domain. And then when we plug negative 6 in here, negative 6 plus 6 is 0, so all of this is 0. What's left? Y equals 2. So in this case, our range would be that y would have to be greater than or equal to 2. Okay, because of this extra 2 out here. I'm kind of getting a feel for this a little bit. So it's good to be able to kind of do a few of these by hand. A lot of times you can see this on the calculator pretty easily as well. All right, let's look at the next thing. Okay. Remember, we just talked about the parent function, and this is how you can transform a square root function. And it's very similar to some stuff that we've done before. Remember the h and the k here and the a out front? Okay, very similar to several other things we've done before, and basically it works the same way. So from that parent function, this k here, that tells you how far up or down it moves from the parent function. This in the middle of the h, remember, it's x minus h, so this is where it's kind of like reversed. So if this is like minus 5, that'll actually move it 5 to the right. Or if this is plus 5, that counts as minus and negative, so it'll move it 5 to the left. So this is the one that's kind of a little backwards, but it's the same as it did before. And then the a, remember, will, if it's a bigger number like 2 or 3, it's going to stretch it. It says down here, stretch it vertically, which means kind of like make it longer and taller. And if it's like a fraction of some sort, it's going to be compressed, so it's going to make it kind of flatter. And then if it goes negative, like I said before, if a goes negative, that's the less than 0 part here, then instead of the graph going up, it's going to then go down. And we'll see an example in a few minutes here. Okay, so works so the same way. So basically, if I go back to the last slide there, remember what we just said, that this 2 tells me how far up or down to move it. Well, where did this, remember our parent function, this started at 0, so what did it do? It went up 2. The range went up 2, and remember this was like the reverse one, you know, so if this is plus 6, it counts as minus a negative 6, and so that means you move it 6 to the left, and that's where our endpoint was. It went 6 to the left. So you can kind of see sometimes pretty easily what's going to happen there. All right, let's do a few examples here. All right, so here's something that you will do on the homework, or the classwork, as I should say. We're going to graph this function and then just state its domain and range. So what I would do pretty much on all of these, it's nice to kind of know some of that stuff that we just did, but for the most part, let's see, I'm going to maybe put this over here. For the most part, just using your calculator is going to be about the easiest thing to do here. So remember, f of x really just means y. So we'll turn this on, go to the y equals button, and then we'll type in 3. The square root is right here, second function, and then square root, and then x minus 4. Now, since that's the end of the parentheses, you want to close. You notice you got or end of the square root. You're going to close your parentheses here. That means that's the end of your square root. Then this minus 2 will go outside of that. So then minus 2. Okay. So when you're typing this in, the x, whatever's under the square root, that goes in the parentheses over here. Then you can do your minus 2 out here. Okay, so let's just look at the graph first of all. It's going to look something like that. Okay, remember it starts at a point and it kind of curves up. So let's do second function table. Look at all that. This is what I was talking about. See this? Error, 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 error. All these errors here because that's where we get it to the where this goes negative under the square root, and so we can't have, those aren't options that we can use. So if we looked at this, actually before I graphed this, we should have looked at this first before we called this up here. But where this should start would be where x is what? 4, because it's the opposite of this one, and then negative 2, because this is moves it down too. So we should have been able to tell right from the start here that 1, 2, 3, 4, negative 2 would be the starting place. And if you notice on the table here, notice 4, negative 2. So you know, we got 4, negative 2 as one of our points there. What else do we have? 5, 1. So I'm going to go 1, 2, 3, 4, 5, 1. Now you notice on these what's going to happen, you're going to get a lot of crazy decimal numbers. Sometimes you might have to use those and just round it off, but I usually try to find good numbers as best I can, like 4, negative 2, 5, 1, 8, 4. So 1, 2, 3, 4, 5, 6, 7. It was kind of 8 and 1, 2, 3, 4. I'll be about right here. So that's going to give you a good feel for it, and it would look something like that. And if you notice, when we looked at the graph, we go, yeah, that's kind of what it looks like. Okay. So what's the domain and the range? Well, you can kind of look at what we did before, or pay attention to this first value, this first dot here, because the domain are all the x's greater to the right of that, and the range are all the numbers above that. So what does that mean? Your domain is where x is greater than or equal to, what is this number here? That's 4, which comes from this. Remember this one, the opposite of that one? And your range, y would be greater than or equal to, again, it's from here, so what's that? That's at a negative 2, which is the same as this negative 2 here. So that's why I say on the calculator, it's kind of easy to find these. So domain x is greater than or equal to 4, range y is greater than or equal to negative 2. Not too bad, right? All right, let's look at the next one. All right, so now here's a new function. We're going to do the same way here, though. Plug this into our calculator. So go back to the y equals. I'm going to clear it. Notice there's a negative out front this time. All right, so this is your negative button down here. You use this one for subtraction. This is your negative button out front. So if you get an error when you're typing these in, check to make sure you're using the negative button at the beginning and the minus button in the middle, because if you switch those around, the calculator doesn't like it. So at the beginning, I'm going to type in the negative button, and then second function, square root, gives me the parentheses there, so I'm going to type in x plus 5, close the parentheses, then I'm going to do plus 6. Okay, so this is what I've typed in to get this. Now, before we go any further here, what do you think our starting point is going to be based on these numbers in here? Okay, remember, the x, our starting x, is going to be basically the opposite of what's in here. So if it's plus 5, that means we think we're going to get a negative 5 for x, and whatever this is, positive 6. That's where we think this graph should start. Let's see if it does. Second function. I don't know if I can second function table. And let's scroll out to negative 5 here and see what we got. See, here we start running in all the errors. What's the first one we got there? Negative 5, 6. Just like we thought. All right, so we got negative 5, 6, and then we have negative 4, 5. And it looks like I've got a negative 1, 4. It's a good number. Maybe we can do one more here. 4, 3. So let's graph those. Negative 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, way up here. Negative 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5. Negative 1, and 1, 2, 3, 4. And then 1, 2, 3, 4, and 1, 2, 3. So you can kind of see what that's going to look like there. And so it's going to kind of something like that. It's not going to actually fall off at the end there, but I just slipped off the edge of my drawing pad. But it'll look something like that. So let's take a look and see on the graph here what it looked like. And guess what? That looks pretty much like what we got. So what's our domain here? And what's our range? So what's the domain? The domain is, if this is the kind of our starting point, it's all the x's to the right of that. So x has to be greater than or equal to, what is this? Negative 5. And this time with the range, this time here's the end point, but where are all the points? They're not above this, they're all below this. So this is where we'd have to say y is less than or equal to 6. So that's where we'd have to do the less than thing there. Okay? So that's if you get a negative in front, it's going to go down like that. Okay? One more, I think, and then we're done. The last thing that we got to take a look at is graphing a square root inequality. Okay, just like we've done inequalities before, you pretty much can find the border by doing it as if it was equals, and then if y is greater, shade up. If y is less than, shade down. And if it has an equal sign, it's solid. No equal sign, it's dotted. So pretty much it's all the same stuff here. Okay, so it's just with square roots. So let's just start the same way here. I got to turn this back on since it turned off. And I'm going to type in here, since some of you can put the greater than and less than stuff in here, I don't know how to do it. So I'm just going to do this as equals. So I've got y equals the square root of 2x plus 4, close parentheses. There's nothing outside here. Okay, so we're done there. So before we figure out where this is, what do you think? Again, based on what we've done before, where do you think that first x is going to be? It's going to be whatever makes this 0 in here. So what would that be? 2 times negative 2 would be negative 4 plus 4 is 0. Again, if you wanted to do 2x plus 4 equals 0 and solve that, you'd find this. And what's the number out here? There's no number out here, so that means y should be 0. So our first point should be negative 2, 0. Let's see. Let's go up. There's the error. There's where we start seeing all the errors. So negative 2, 0 is the first point that comes up. That's perfect. It looks like we got a point at 0, 2, which we could use pretty easily. And then let's see if there's anything else here. 6, 4. We might be able to fit that on our graph. 6, 4. All right, let's use those points. Negative 2, 0. But now, okay, one other thing that I didn't mention. Remember, when we do the dotted and solid line, that also will apply. Before, we didn't really have an endpoint. We would just draw a dotted line through everything or a solid line through everything. But we have an endpoint here. So remember when we used to do our number line graphs, when not on an x and a y coordinate plane, but just on one line, we do an open circle if it was not equal to. We kind of have to do that here too. So here, is there an equal sign? Nope. So I'm going to make an open circle on negative 2, 0. Then I'll plot the rest of these. 0, 2, and 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So that's going to be our line. And now, this might be hard for me with what I've got here. Usually what I do is I'll like draw this curved line and then I'll go back in and erase some spots to make it dotted. But that's going to be hard for me to do with my little fake pen here. So I'm going to try to make this dotted as we go. Don't laugh at me if it's not good. That's not bad. So it's a dotted line because there's no equal sign, and open circle because no equal sign. And then we just have to figure out, do you shade above or below? And in this case, if y is greater than means above. So, and it's above this line, and it stops. Since this is the stopping point of -2 here, it stops basically at that point. So the shading doesn't continue over into here. The shading stops basically right along this line here. Okay, so it's just going to start shading at that point, -2, 0, and it's going to shade all that over here. So that's what your graph would look like. Okay, so we did a little bit of graphing with square roots and square root inequalities. Remember, with the inequalities, everything still is the same with the solid and dotted lines, and the shading above and below. It's all the same. And again, for most of these, I just plug it into my calculator and then see kind of where that end part is. All right, that's it. That's all we got. I'll see you guys next time. This is Mr. Anderson signing off. Sayonara.